Alright, so in this video we're going to see case 2. So once again we have our generic homogeneous differential equation ay double prime plus by prime plus cy equals 0, which I'm going to refer to as star in the future. The characteristic equation is ar squared plus br plus c equals 0. And applying the quadratic formula to that, we get that r equals negative b plus or minus b squared minus 4ac over 2a. In case 1, b squared minus 4ac, which is the discriminant, no, not the determinant, discriminant, was bigger than 0. So case 2 is where b squared minus 4ac equals 0. Okay? So basically we have a double root. So that means we have one real double root, and I'll just call it R1. And a lot of times when I'm writing this, we'll say R equals, and I'll say a number, and I'll write dr next to it, meaning it's a double root, just so if you see that in the future. Okay, we've already shown a couple things. So back in the characteristic equation video, I showed you that if R1 is a root, e to the R1t, or x, was a solution. And if R1 was a double root, I also showed you that x e to the R1x, or in this case I'm going to say t's. So t e to the R1t is also a solution. So here's the deal. So the claim would be that my general solution is c1 e to the R1t plus c2 t e to the R1t. Now get used to this. So the way to, if you have only one thing and you need to make something else linearly independent from it, this is how we do it. Okay, so we take the thing that we had and you multiply it by t, and that makes something that's linearly independent. So I guess a theorem would be that e to the R1t and t e to the R1t are linearly independent. Okay, so our proof would once again involve the Wronskian. Okay, so we're going to do our determinant thingy for the Wronskian. It's going to be a little bit more complicated because I need the product rule in this one. So I have e to the r, oops, up there, e to the R1t and t e to the R1t. Okay, I'm making a little bit more room because that one's going to have two terms. So we've got R1 e to the R1t, and then here we've got e to the R1t plus tr1 e to the R1t. Okay, and then those multiplied, and I'll distribute through. Now notice that, once again, same bases, so we add the exponents are the same, so we'll just say 2. So this is going to be e to the 2 r1t, that's that times that, plus t r1 e to the 2 r1t, so that's that guy times that, and then we do this, so we're going to have minus t r1 e to the 2 r1t, and look at that, those two terms cancel, and we get e to the 2 r1t, which is an exponential function and can never be equal to 0. Yay. So from that, we're going to go straight into an example. And I'm just going to get a general solution here, which is going to take no time flat. So we're going to solve y double prime plus 4y prime plus 4y equals 0. Okay, and your very first step is to write that characteristic equation, which is really simple. So r squared minus 4r plus 4 equals 0. And this factors quite nicely. This is r minus 2 squared. So we get that r equals 2. And once again, remember my notation, dr means double root. So what is the general solution for the homogeneous equation, it is C1 e to the 2t plus C2t e to the 2t. Done. Move on. Next question. Pretty easy, right? All right, case 3 coming up.